everyone, in this tutorial I am going to show you how can you make AV3 robot moves in a square and making perfect turn. Let's get started. Before we start talking about turns and move in a square, let's talk about the AV3 motors. We know that AV3 motors need a power to turn on. Now, if I want the AV3 motors, the large motors or the medium motors, the both motors, if I want them to move forward, I need to give them a positive power. And if I want them to move backward, then I need to give them a negative power. So negative and positive power will affect the backward and forward movement. Let's talk about the motion system. If I have one motor, I expect my robot to behave in two different ways, to move forward or to move backward with no rotations. So we are talking about only two movements. If I have two motors, I can make 12 different moves. I can move straight, forward and backward. I can make swing, turn, forward and backward, and we can make point or steering turn. Let's talk about the straight move. To make the robot move in a straight line, I need to give the two motors the same directions and the same distance and the same speed or the same power. So if I give both of them the same power, distance, and the same direction, the robot will move forward. If I want again to move it forward, I have to give positive value for the power, for the speed. To move straight backward, I have to do the same thing. I have to give the same speed, the same direction, and the same distance. But this time, the value or the power is going to be negative because I want the robot to move backward. Let's talk about the swing turn forward. If I give the right motor a positive power to move forward, while the other one doesn't have any power, the left motor doesn't have any power or the power is zero, what's going to happen, the robot will swing turn to the left side because the left motor is off, the right motor is on, so the right motor will move the motor to the left side. So the same thing is going to happen if I give the left motor a power while the right motor zero. What's going to happen, this motor will continue moving forward while this one is off, so it will turn to the right side. So here we turn to the left side, and with this robot we turn to the right side but to the forward direction. What if I wanted to turn to the left side, to the right side, sorry, but backward? So what's going to happen, I have to give this one, the left motor, a negative value while this one is zero. So the negative value will make the robot move backward, and this one zero will make no action. So the robot will move this direction to the right side. The same thing is going to happen if I give the right motor here negative value while the other one is off. So the right motor will go backward because it's negative value to the left direction. This is the swing turn forward and backward. We have another kind of turn called point or steering turn. When I have two motors, will move opposite of each other with the same speed. Opposite of each other means like one will have a negative value while the other one will have a positive value. So in this picture, the right motor will have a positive value which will make it move forward, while the left motor will have a negative value which will make it move backward. So what's going to happen that here the robot will spin while it's on the same position. and this is what we recommend when we perform turn. In this part of the picture, we will have the same thing. If I give the left motor a positive power, the robot will move forward, and the right motor will have negative power to move backward. So the robot will turn to the right side and it will spin while it's on the same position. We call this point or steering turn our spin. I want to conduct a comparison between two kinds of turns. Like, we recommend the point or steering turn because the weight of the robot will be distributed on two motors, because two motors are on at the same time. But if we talk about the swing, one of the motors is off while the other one is on. So the weight of the robot will be on one motor only, which might cause some problems. And the other thing, if we want to talk about the position of the robot, as I mentioned before, if I'm using the point or a steering, the position of the robot will not change. What's going to happen? The robot will perform turns left or right without changing the position, while it's going to change if I use the swing turns. Now, let's see how can we move the robot, how can we code the robot to move in a square. As we know that the robot to move in a square, we will have like, to start from here, we're gonna have like a straight line, a number of rotation. So what's gonna happen, I'll go to the movement, and then we're gonna decide that I want to take, first we will set the movement to the power, to the motors. It's gonna be B and C, because we see here in the program that our motors are connecting to B and C ports. So set movement to the motors B and C. Number 2, I'm gonna go and say that we want to move straight. We will use the move steering, which is move straight for one rotation with this amount of speed. Let's try the code now. Okay, the robot moved forward for one rotation. To reach this point, we need to increase the number of rotations. So I can say, like, I'm gonna make it 1.5, and I'll take the robot back to the start position. Okay, I think this is perfect. Now my robot needs to perform turn to 90 degrees. Use the kind of turn which I can stop one of the motors while the other one is on. So I'll go to this, move for one rotation at 50-50 speed. Now my robot has to turn to the right side. As we see here, the robot has to turn to the right side. So to make this robot move to the right side, then the right motor, what's going to happen? If the right one is on, off, 0, then this one will take the power. So let's go take, the B is this side. I'm going to make this positive value to move forward, and I will make the other one 0, so it can turn to the right side. Let's lower the speed of the power, because if you make turn with a higher speed, your robot might drift. So let's make it 30 power, and let's try again. Perfect. Okay, so now my robot moved first in straight line and then turn 90 degrees. Okay, to make the robot move in a square, then I have to repeat. It has to move the same amount of rotation for the line and the same degree or the same amount of rotation for the turn. So we can copy paste. I'm gonna do Ctrl C to copy the two lines of code and Ctrl V to paste it. So I'm gonna put them together and stick them to the block. I will try now the code again. Okay, so, and I will continue. So my robot moved for in a straight line, then turn 90 degrees, straight line, turn 90 degree. Okay, we have to add these two lines two more times to continue with this line and go back to the starting point. And instead of keep writing, I can make Command C, Command V, or Control C, Control V, Command C, Command V for the fourth line. Let's go there. And let's test it for the last time with this code. Perfect. Sorry for the space. So my robot moved in a square now using this code. If I want to make my code like shorter, I can do something called loops. Like I can say repeat. I'm gonna repeat. So the robot needs to move straight, and then it will turn 90 degrees. Now we have four lines, so the robot needs to turn the two commands, which is move straight, turn 90 degrees. It's gonna be for 4 times. So we will repeat 4 times. Thank you for watching.